Hello everyone. In this video, we're going to be simplifying a radical expression. We have the square root of 2 plus root 3 minus the square root of 2 minus root 3. And we're going to simplify this expression. And I'll be presenting at least two methods, probably three. So let's go ahead and start with the first method. For my first method, I want to go ahead and look at this problem from a radical perspective. What I mean by that is what would happen if we only had this and we wanted to simplify it. In other words, denest the square root, right? So denesting is basically you have something like the square root of a plus root b, and you want to write it as square root of x plus square root of y, where no radical is underneath another radical. Make sense? Okay, this doesn't always have to be with square roots, as you know from some of my previous videos, which I could probably link here if I don't forget. It's not always going to be square root. Sometimes the other roots will be involved, depending on the level of the problem. One problem that we did recently was kind of on the harder side. But anyways, that's the goal. So let's go ahead and take a look at this first. Because if we can figure this out, the other one should be fairly simple, don't you think? They're conjugates. So we could safely say that if the square root of a plus root b is equal to this implies that the square root of a minus root b is equal to root x minus root y. But we do need some requirements. There are some requirements for this to be true, which is basically like if you think about this, multiply these two things together, you're going to get the square root of a squared minus b under the radical. And on the right-hand side, you're going to get x minus y from difference of two squares. What that tells you is if x and y are rational numbers, this is a rational number. That means this is a rational number, which means a squared minus b needs to be a perfect square. Does that make sense? So as long as that is satisfied, we're good to go. Now, can we check that here? Absolutely. A is 2, b is 3. So a squared minus b, for our case, is going to be 2 squared minus 3, which is 4 minus 3, which is 1. And 1 is a perfect square, as you know. It's not the best one, but it's actually the best one, isn't it? So what does that mean? It means that I'm going to assume that the square root of 2 plus root 3 can be written as square root of x plus square root of y. Now, if you write it that way, there's a better way to write it, by the way, I'm going to show you. And square both sides, you should get something like this, right? Square both sides, you're going to get 2 plus root 3. On the right-hand side, you're going to square these, which is x plus y, and then 2 times the square root of xy. Now, if x and y are rational numbers, you can safely say that, hey, this is supposed to equal x plus y, and 2 square root of xy is equal to square root of 3, which means that 4xy is equal to 3, which means xy is equal to 3/4, and x plus y is equal to 2. So we got ourselves a nice system, which is quadratic, right? So what are we supposed to do? Solve for x and y, because that'll give you the answer. There's obviously another way to look at it, which I'm going to show you. So it's kind of going to be like method within a method, okay? So if you solve that system, and there's so many ways to do it, I prefer isolating y and then substituting that into the first equation like this. So replace y with 2 minus x and then solve the resulting quadratic. Obviously, from here you can tell x is going to be rational, but not an integer, right? You got that? And you can test some values here, like could it be 1/2, could it be 3/2, so on and so forth, as long as you're picking something less than 2, because this is supposed to be positive. This also tells you that x needs to be between 0 and 2, I think, right? Okay. Anyways, let's just solve it. No big deal. 2x minus x squared is equal to 3/4. Put everything on the same side. X squared minus 2x plus 3/4 is equal to 0. You can either use a quadratic formula. You can complete the square. Again, there are so many ways you can branch out. I'll probably just complete the square because that's kind of easy. I'm going to go ahead and subtract 3/4. And then what am I supposed to add to both sides so that the left-hand side becomes a perfect square? And the answer is here. What's half of 2? 1. What's 1 squared? 1. So you're supposed to add 1 to both sides. And when you do, the left-hand side becomes x minus 1 quantity squared. This is a trick that we always use, so you should be familiar with that, especially if you're going to do algebra or if you're doing algebra. And algebra is my favorite, needless to say, right? There's another channel which is called aplusbi, which focuses on complex numbers. But if you like trigonometry, geometry, a little bit, tiny bit, number theory, SyberMath is the channel for you, but also check out aplusbi. Now from here we get two solutions because there are two numbers whose square equals 1/4. Remember that. X minus 1 can be 1/2 or x minus 1 can be negative 1/2. This means x can be 3/2. This means x can be 1/2. Which one is correct, right? And I would say both. Why? Because if x is equal to 1/2, then y would be 2 minus 1/2, which is 3/2, and vice versa. What this means is if one of them is an x value, the other one is a y value. And it doesn't matter because x and y are interchangeable. Remember, we wrote our expression as follows. We said that, okay, let this be square root of x plus square root of y, which from the commutativity property, it's kind of hard to say, they just commute, they switch, okay? I wish they found the different name for this, like maybe switch property or something like that. Anyways, get the idea. So you can take anything for x, 3/2 or 1/2 doesn't matter. But if you want it to be bigger, let's go with the 3/2. So square root of 2 plus root 3 can be written as the square root of 3/2 plus the square root of 1/2. So did we actually denest the expression? We did. Notice that here 3 is under 2 radicals, but on the right-hand side, no number is under more than 1 radical. Okay, that's the goal. Of course, you can write this in different ways, such as you can separate these two things, and then you can kind of write it like this, and then make a common denominator. Square root of 1 is 1, and then use the not complex, sorry, I got carried away. I was thinking about a plus bi, I guess. But you can rationalize the denominator, and you're going to get something like square root of 6 plus square root of 2 divided by 2. This is probably the best way to write it, and I would say the simplest form, in my opinion. People differ, but that's how you can write it. Okay, what about that? If this gives us that, what happens if I change this into a minus sign? Automatically, this turns into a minus sign. So you get the answer right away real quick. So the other one is just going to be root 6 minus root 2 over 2. And if you go ahead and add these two things, the root 2 is going to cancel out. You're going to end up with 2 root 6 divided by 2, which is equal to square root of 6. Whatever that is, it is the most accurate form of writing it. The square root of 6, the exact value is the square root of 6, okay? So that's the answer, but that's a lot of work, don't you think? Of course, you could also approach it slightly differently, like, okay, I can take this, and instead of writing it as square root of x plus square root of y, I can also think of it this way. Maybe I can write it as a plus b root 3. Right? And then what does that mean? This is going to be written as a minus b root 3. Absolutely. And then you can just go ahead and do something like this. You can multiply these together. That's going to give you 1 equals a squared minus 3b squared. That gives you one equation. And then you can square one of these, and it should give you something similar. And you're going to find the values of a and b, which are going to be rational numbers, fractions, by the way. Okay, so that's one way to approach it, but this is not the only way to approach it. So here we go, second method. Now, instead of looking at these separately because they're related, right? Why don't we look at the sum, right? Like think summatively. So instead of trying to find each one separately, even though one gives away the other, why don't we just call this whole thing a or x, whatever variable you like. Doesn't matter. And don't worry about the a we used before. Okay, fine. We're just going to call it x, z, whatever. And then square both sides. Because wouldn't that be easier? Our goal is to get to this as fast as possible. Square both sides. And then now, on the left-hand side, you have a plus b, or the sum of two things. When you square, you're going to get a squared, b squared, and then plus 2ab. But remember, this is 2 times 1. Because when you multiply these two things, you get 4 minus 3 from difference of two squares. Did I tell you? Difference of two squares is super duper important. You have to memorize it, okay? Very important. And this is equal to x squared. Now notice, this is really clean because square root of 3 cancels out. You have 2 plus 2 plus 2. Who said math is hard? It's as easy as 2 plus 2 plus 2. X squared equals 6, and this implies x is equal to square root of 6. And we know that x is positive because this is a positive quantity, this is a positive quantity. Their sum has to be positive. And yes, we got the answer in a much easier way. That's what's really cool about second or third methods, because they are usually better or more elegant. But again, you're going to decide which method you like better. Everybody is different. Just let us know what you think in the comment section down below. Okay? Now, is there another way to do this problem? Absolutely. I'm going to show you the third method, which is as a bonus. And this is really cool because you need to be familiar with these things. Okay? Now, we have a minus sign, I think, right? Did I put a minus sign, plus sign? Okay, what was the original? Uh-oh. I hope I didn't mess up on this one. I think that was a minus sign. Okay, never mind. Then should we not get a minus sign? Uh-oh. I think I messed up somewhere. Let's check. We should have a minus sign. Then first method is also inaccurate. But anyways, you get the idea. So, oh yeah, there should be a minus sign here. Let's correct this. I just realized like the original problem didn't have a plus sign. Of course, the square root of 2 is not going to cancel out. Okay, can we just start over here? Root 6 plus root 2 over 2 minus root 6 minus root 2 over 2. And since we're subtracting them, the root 6 is going to cancel out, giving us root 2 as the final answer. Okay, that should be the answer, root 2. And here we should get the same thing. If we change this to a minus sign, everything should work out, hopefully, right? This should be a minus sign, and that should give us, instead of 6, 2 plus 2 minus 2. These two are going to cancel out, giving us 2. And at the end, this should be the square root of 2 as the answer. Now, let's go ahead and proceed with the third method because we fixed the first two. Now, here's how it goes. Now, this expression, I want to go ahead and multiply this by root 2 and divide by root 2. Let me tell you why I'm doing it, first of all, right? Now, when you multiply the inside by 2, so it would be better if we had this instead of that. Why? Let me tell you. If you go ahead and take like square root of, okay, how do I explain this? Okay, take square root of x plus square root of y and square it, okay? When you do, you get x plus y plus 2 root xy. Remember, we did this with the first method, right? So it's better if we have a 2 in front of the radical, the inner radical. Because if we square root both sides here, we're going to get something like that, assuming that x and y are real and both this is sum is a positive. We're going to get something like this, okay? So basically, the whole idea is you want to get a 2 in front of the innermost radical. So in our case, we have this, right? But we don't have a 2 here. The 2 is missing. Well, you can get a 2 in there just by multiplying by root 2. That'll give you 4 plus 2 root 3. But of course, you have to do it with the other one as well. And you can't just multiply them. You also have to divide by them. But we'll do that later. Now, what is that equal to, right? If you look at this carefully, you're looking for two numbers whose product is 3 and whose sum is 4. And those numbers are 3 and 1. So in other words, this can be easily factored like this. 3 and 1, this is the sum. So this is root 3 plus root 1, which is root 3 plus 1. Okay, makes sense? But again, don't forget to divide by root 2 because you multiply and now you need to divide. So let me show you how that works in the big picture. We have this, right? Again, I put a plus sign. I don't know why. I just like the plus sign better. You know, it's more positive, isn't it? Now, we're going to do the following. We're going to multiply by root 2 and divide by root 2. Makes sense, right? Because we're multiplying by 1, basically. And now, if you distribute it, you're going to get the square root of 4 plus 2 root 3 minus the square root of 4 minus 2 root 3. And all of that is divided by root 2. Now, you got to remember, this is root 3 plus 1 or 1 plus root 3. Now, is the other one going to be root 3 minus 1 or 1 minus root 3? That's a good question, right? But notice that this is a positive quantity because this is the square root of 12. This is the square root of 16. So it needs to be square root of 3. Uh-oh, we're done with black background. Root 3 plus 1. And the other one is supposed to be root 3 minus 1. We're supposed to subtract them and divide by root 2. Let's do it. This is going to give you 1. Wait a minute. The root 3's are going to cancel out. We're going to get 1 plus 1, 2 divided by root 2, which is root 2 as before. It is the answer. And this is the end of the third method. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.